Hi everybody, Simul here, and in this video I'll be tackling the famous LeetCode problem number 146 called LRU Cache. So let's just directly jump into the problem statement. So what this problem asks us is to design a data structure that follows the constants of LRU cache or least recently used cache. So what are the constants? If you click on the link, you'll be able to see the constants, but let me directly explain you better. So let's just directly jump in the whiteboard. So there is a cache with a certain capacity. For example, if the capacity of the cache is 2, so we have two spaces where you can put in values. And for now we are filling like a key value pair in this cache, but you can put in anything, but the problem asks us to do that. So first, let's say we are putting it 1 comma 1 in the cache. It's empty, and then next we are putting in 2 2. So based on our assumptions, like as you can see, like 2 2 is the most recently used and 1 1 is the least recently used. It's because 2 2 was used just now, whereas 1 1 was used before that. So the ordering should not be this way in real world implementation, but for the sake of solving the assignment or the problem, let's just say that towards the left side we always have the LRU, and then once we gradually move towards the right side and reach the end, then the rightmost will be the MRU. That means so whenever we are trying to insert a new key value pair and the capacity is full, the first constraint is that we always need to replace the like remove the LRU out of the cache, because that was least recently used and it's not used in the recent times. So for example, if we are inserting 3 by 3 3 comma 3, the key value pair, we remove the LRU. So there's two steps to this. First, remove the LRU, and second step is insert this 3 3 on the MRU position, because this was used the latest, right? So most recently used. That means 2 2 goes over here, 3 3 goes over here. So this is the first constant, and the next constant is, now as you can see, 2 2 is LRU, right? And 3 3 is most recently used. But there is one more so we just put 3 3. There's one method initially that you already seen, apparently, that there is a put method, but now there's a get method too. So whenever we are getting a data, for example, LRU 2 2 is LRU, right? So we are doing a get call on this cache, which will return, this is key, this is value, right? So we're returning the value for the respective key. So whenever you're doing a get operation, this also means that this key value pair is just used, has just been used. So what do you do in this case? We have to make sure that we move this to the MRU position, because this was just used. So there are two steps to this, again similarly. So first thing is you remove this from the cache and insert it again to the cache. So now our new cache becomes this. And the problem asks us to do this in average time complexity of constant. So as we know, the best data structure to use for this would be hash map. So again, like it asks, we have like two methods and one constructor. So the problem asks us to design to code for each of these. And the first one, constructor, we what do we do is we initialize the cache with a user defined capacity. So we just did 2, right? So it can be any variable, and two methods, as we said earlier. One is get, one is put. So that's what we need to design, and each of those should run in constant time complexity. So before we jump into the code, let's just uh, see like what kind of data structures we might require, and how do we go about the solution. So as I've said, since we need like a constant time complexity, the best data structure to use is hash map. So that's why we have a hash map where we have key value pairs. For example, we have 1 1 and we have 2 2 value in the list. So we have a key value pair, that means 1 and we have 2. Suppose capacity is 2 over here. So key and value will be obviously 1 and value will be obviously 2, right? So that whenever we are accessing this, we can directly use the hash map and access it. We can do get, that is the fastest and constant time. So this is a hash map to keep a record of that. But one more thing we need to realize is that we need a pointer over here, because you remember when I said that we need in the get and put methods, what we need is get and put methods. We need, there are two operations that we have to do. One, we have to remove the LRU and we have to insert in the MRU position. So to remove the LRU, we need to know the position of LRU, right? So how do we do that? The best data structure we can do that, like the easiest way is using a linked list, right? So if there's like a dummy pointer called LRU, so LRU.next will always be pointing at the least recently used key value pair, right? Similarly, we have a dummy pointer called MRU, and if this points, so the previous of MRU would always be the position that we want to insert, right? Right. So that's why again, if this is pointing back, that means we need a doubly linked list. So that is a data structure we are going to use along with the hash map. And again, one more thing, like instead of putting value over here, it's a better idea to put the reference of this whole node here. So why, you might ask, is because whenever we are doing any kind of operations like insert and like get or put, we might have to insert and remove, right? Like the nodes. So for example, let's just say we are we're removing this 1 1 and putting it over here at MRU positions. That might be the case, right? So in this case, even if we change the order of like if you're moving this around, the order is being changed, right? So we don't have to care about that order change in this key value pair if this is a reference, because this reference doesn't matter. The key is always one, it's always pointing. So the reference is being moved, right? So that is one reason that we might have, it's better idea to use the reference. Yes. So that's it. Let's then jump into our code. So the first thing we would need is like a doubly linked list implementation. So let's just create a public class called node, and in this we need like since we are our key and value both are integers, right? So we have key and val, and then since it's a doubly linked list, we need node previous pointer and next pointers, and then we'll have a constructor that will take in the key value pairs, and then will initialize this dot key equals to key and this dot val equals to val. And also initially what we can do is since initially there's no values to the values on the linked list, so LRU or dummy node and MRU dummy node, it's gonna point at each other, right? Because there's no values. We're gonna do that also when we initialize the cache. So but for now our priv, whenever we initializing, it's null, there's nothing here, and next is also null. Yes, so that is our node class. And now a couple of things we need. We will need capacities to store the reference object, and we need a cache, right? So what how do we represent the cache? Using a hash map, right? So we need a hash map. So as we said, the key is always the integer, whereas value is not an integer, rather it's the reference to the node. So it's gonna be a node. Let's name the cache as cache. So we'll initialize it in the constructor, which is gonna define it right now. And then we need what do we need? So so this LRU, let's name it as left, and MRU will name it as right. So these both are like dummy pointers whose value we don't really have to worry about, but it's just gonna point to the LRU, and technically this is the LRU and this position is MRU, right? So let's just do node left and right, and then yeah, that's about it. So in the constructor, what do we need to do? So the first thing we need to do is we need to initialize the cache, right? The hash map. First new hash map. So we've done that, and as I've said earlier, so the sorry, this should have been left and right. So left should be pointing to the right, right should be pointing to the left when there is no items initially. So let's do that. Just a new node. Before we point, we just initialize both of the left and right nodes as dummy nodes, and then let's point to each other. So left equals left, next will be right, and right dot prev will be left. And one more thing, since we are initializing the constructor with the capacity, you have to set this capacity as well. Perfect. So that's the constructor is done. So now next thing is we need to do get. So for the get operation, what we need to realize is we just need two things. First thing, whenever doing a get operation, we need to know if that key value pair exists or no, right? It says right over here, if it doesn't exist, then we can return -1. So if it exists, we'll do some kind of operations, otherwise we're gonna return -1. So how do we check if the value exists, right, in the cache? So we don't have to look at the linked list, we can just directly look at the hash map, right? Because every node corresponding to the linked list is present as a key value pair in the hash map. So let's just do that. So if, how do we get the value from the cache? The hash map cache dot contains key, I guess. Key, and we have the key as the input parameter. So if cache dot contains key, so what are we doing? We are doing certain operations, right? But if it doesn't, then we can just return -1. So if it contains key, that means it exists. The key value pair exists in the linked list, right? So what do we do over here? As we said, whenever we are doing a get value, doesn't matter which position the key value pair is. We always remove it and put it at MRU position. That is towards the end of the linked list. So we need to do two things over here. The first thing we need to do is we need to remove it, right? We need to remove this value from the linked list, and the second thing we need to do is we need to again insert it to the MRU position, and then we need to like, since we have to return the value, right? That's what this method is. So then we have to return the respective value. So let's do that. So we are gonna create a method called remove and insert, which is gonna be a helper methods, which are gonna be helper methods. So remove helper method and insert helper method, right? So what remove is going to do is remove the uh, uh, node from the linked list, right? And what we insert is gonna insert the node at the MRU position, that is towards the rightmost position. Okay, so we're going to worry about these helper methods later, but just for the sake of simplicity, what we're doing is remove is going to remove and insert is going to insert to the right. So let's just remove. So what are we removing? We are removing the current node, right? So how do you get the reference to the node? Since we already have the key, if we get the value for that key, that value is the reference to the node, right? So we have to pass the node. So we can always do that using cache dot get key. So what this does is cache dot get key. Cache dot get key is returning that node, and that we are passing that node in the remove method. So both the remove and insert method takes in the nodes. So after we remove that, we need to again insert it to the MRU position, right? So that's why we again do insert cache dot get key. So the key is always in the hash map, right? The cache, right? It's so whenever we removing, after it removes, this method removes it from the linked list, the value is again still gonna be in the cache, and then we are gonna get this value again, and then we're gonna insert it in the MRU position. So after that is done, the final thing we need to do is we need to return this value, right? So how do we return the value? We can do return cache dot get key. But since cache dot get key is like the reference to the node, so how do we get the value of the node? Just dot val. That's all. So yeah, that's also done. Now it's time to do a put operations. So the put operation. So the put operation is similar to get. So as I said, whenever you're putting some kind of value, what we need to do, we need to check first if it exists or not. If it exists, then what we have to do is we have to make sure put will always move that item in the MRU position. If it doesn't exist, doesn't matter. If it still needs to get inserted into MRU. If it does exist, what we need to do is we have to remove it from this position. Suppose we are trying to put 1 1, we have to remove it from this position and still insert it to the MRU or the rightmost position. So how do we do that? First, we need to again check if cache dot contains key, right? I missed a bracket over here. If cache dot contains key, what we are doing is we have the remove method, right? The helper method. Dot get. Yes. So we've removed that. If it doesn't, if the key value pair to be inserted is already there, we just remove it. If it's not there, or if it's either way, we are just inserting the new value, right? So let's just insert. So what are we inserting? We are inserting an actual node, right? So new node key and value from the parameter, right? So whenever we are inserting, how do you insert? So first we need to insert it in the hash map also, right? So how do we do that? We have cache dot put method, and then since this node is the value, right? Node is the value, and we need key also. So key and value. So key is also coming from the parameter, and value and key is also already coming from the parameter as new. So now we have put the new key value pair in the hash map, the cache. So what we have to do now, finally we have to insert. So how do we insert? We already have that in the cache, right? So we can just do cache dot get key, and that will have the node, right? So we are inserting the node into the cache. Now one thing you have to realize over here is we haven't taken care of one important issue over here. So whenever let me just clear out the screen right now. And so suppose our linked list is this, right? We have the left, we have the right, and we have key and value pair, one reference, two reference, right? So two. So in this case, whenever we are putting a value that already exists, so we remove it, right? And then we put 1 1. That's fine. But in this code, if you see is if it doesn't exist, right? If you are trying to insert something new, so this code, the remove code doesn't execute. So we are basically just inserting a new value, a new node key value pair in the cache, and we are also inserting that in the cache and in the linked list. So this definitely violates our rule of the capacity being 2 or whatever it was set. We never looked at the capacity, right? So that's where we need to deal with this also. So now after inserting this, since our capacity is 2, so we have added one extra key value pair in both the linked list and the cache, the hash map. So what we need to do is now we need to remove the LRU from here, from the linked list and from the hash map as well. So taking care of the capacity, right? So how do we do it? We need to check. So how do we check if it's like an extra, like capacity is increased more than 2? So we can check the size of the cache, the hash map, right? So if the size of the cache is greater than the capacity, so capacity is 2, and currently the size has become 3, right? So 3 is greater than 2. That means something is wrong. It's going past the capacity. So what we need to do is we need to remove the LRU. So let's just store the LRU right now. So what the LRU is how do we know that? Here the double linked list comes into play, right? So left dot next is always pointing the LRU. So we do left dot next. So let's just remove LRU. How do we remove? We have our helper methods remove. So that is just going to remove it from the linked list. Now we have to remove it from the cache as well, the hash map. So we have the inbuilt method to remove item from the cache. So how do we remove? We remove it based on the key. So where's the key? So as we know, since the key is for the LRU, right? So obviously we can do LRU dot key, because LRU has key and value we can access, right? So we just need to pass the key which of the key value pair that we're removing, and then that's done. So that is also there. And one more thing I should have mentioned over here is, like, whenever you're doing an insert item, right? For example, you have 1 1 and 2 2 over here. Suppose we are putting like 1 comma 2. Since hash map works in such a way that it will always update the key value pair based on the key, right? If the key is the same and value is different, it's gonna just update. So this is gonna take care of it, right? Whenever you're removing, adding, it will insert. So that's just something that I wanted to mention. Okay. Now, finally, what we need to do is we need to work on the helper methods. So remove, both of them are pretty straightforward. So we can just do removing, we are not returning anything. Inserting also, we are not returning anything. So we can just do public remove. What are we passing? We are passing node, right, for both of these methods. So how do we remove? So whenever you're trying to remove this, what is the previous and what is the next? So previous is always going to be left. Previous is going to be not left, because whenever we are removing a node, this node can be anywhere, right? We could have removed this also or whatever. So we, rather than taking left, we can just take previous as the previous of this node we are trying to remove, and next to be next of the node we are trying to remove. So for example, if to remove this, we can just point the previous to the next and point the next to the previous, and that'll be removed. So what we do is, first we need to take get the previous. So it is node.prev, node next equals to node.next, and then we can just point previous to next and next to previous. So previous dot next equals to next, and next dot prev equals to prev. So the way we've removed the node. Now whenever we are trying to suppose this is MRU, or the right pointer, and we are trying to insert a value over here. So how do we do that? We are trying to insert a value xx over here. So what two things we have to do? First, we have to make sure we have to point the previous to this node and this node to the right, and again right is going to point back to this instead of here, and then this is going to point back. So for this to happen, we need to define what is previous and what is next, right? So how do we do that? Let's see. Same thing with this public insert. Sorry, it's going to be void because we don't want to return anything. It's going to be node we are trying to insert. We're going to insert to the right. So what we can do is first we need to find what's the previous. So previous is always gonna be the previous of right, because that is the MRE right now. So right dot prev is gonna be the previous, and next is always gonna be the dummy pointer, right, which is the rightmost pointer, that is right. Now, so what we need to do, the first thing we need to do is, so previous dot next and right and next dot previous is gonna be the new node, right? So previous dot next and next dot previous is gonna be the new node, and the next thing, this and this is gonna be new node, and the next thing we need to do is node, this node, our current node that we insert dot previous is gonna be prev, and node dot next is gonna be next. So that's straightforward. Node dot prev equals to prev, and prev dot next equals to next. Yeah. So that's all. Just to go through the code, we have like a doubly linked list class, and we initialize our hash map cache, uh, left right positions, dummy positions in the linked list, capacity. That's what we initialize in our constructor, and then we have two methods, get and put. So get is gonna get the value out of the linked list, and put is gonna put it back to the linked list, or the cache. And then we have like helper methods, remove and insert, to help us with this. So fingers crossed, let us try putting this on LeetCode. I don't know if I have any syntax error or something. We'll figure that out. So let's run first. Okay, there is an issue. Cache equals to new hash map. So what is this issue? Let's see. So map equals to hash map. I don't see any cache, right? Maybe it should be this dot cache, right? That's wrong. Oh, my bad. Now I realize it doesn't have to be. That's why I was wondering. Yeah, there's like a colon issue. Okay. Cannot assign feed period because log is now at. Okay, now I see what the issue is. Line number 60. Yes. So remove method. What can be the issue over here? So previous dot prev dot next equals to next dot prev equals to prev. Okay, I faced this issue before. So what I did was it was actually an issue with insert. So node dot prev equals to prev dot next equals to so it was an issue with the insert method, right? So let's double check the insert. Whenever we are inserting a value, the previous is right dot prev. Okay, next is this dot right. So prev dot next and next dot prev equals to node. Okay, correct. Okay, there's the issue now. So node dot prev, this should have been node dot next, because we're doing node dot prev and node dot next. Perfect. Let's run. This should work. Voila, there you go. Let's just submit. Okay, successful. So yeah, thank you everyone for whoever has managed to watch this whole video. This was my first attempt in doing this, like a recording a LeetCode problem solution in a video. And the reference, I've been definitely taking a lot of help from a very amazing YouTube channel. It's called LeetCode. Do check it out if you guys are interested. And there are a lot of other LeetCode problems that I really like. So this is not one of my favorite, but I really found out this was very interesting. So I just give it a go. But hopefully I'll be bringing out more of these solutions. And please feel free to give me feedback if this was not clear, or constructive, any kind of constructive feedback. Oh, most welcome. So yeah, thank you so much. Have a great day.